Good morning, everyone. Today we will start our fifth unit, and in fifth unit there are two major topics. One is pointers in C, and another is file management. Okay, so with these are the two major topics in fifth units, and we'll start with the pointers today. Okay, pointers is normally when people learn C programming, pointers is considered to be a slightly difficult topic, difficult to comprehend. But here we don't go into so much depth of pointers topic as such, so it should not be that difficult for you. But anyway, today I'm going to cover very basic concepts about pointers. So you carefully listen to this class, and if things are not clear to you, you can watch the videos one more time or approach me directly. But it's simple only. Probably people find it difficult because maybe it is not explained in the right way to them, or the way they want, the simple way they want. I will try my best to explain it to you in a very simple manner, but you have to attend it carefully. Okay, so we'll start with a diagram that we have seen before. This one, several times I have shown this one, this diagram. This is the view of computer memory. Like, we can visualize it as a linear sequence of bytes. This is one byte, this is one byte, this is one byte, like that. Okay, and I have told many times that every byte in memory is assigned with a unique address. So this byte, I'm assuming that the address is normally a number, integer value, normally an integer value. So this byte is assigned with the address 1000. This is just for example I am taking. Address will be a larger value, typically a 64-bit value or a 32-bit value. Here, like, I am representing it in decimal system. Anyway, numbers we can represent in binary number system, decimal system, hexadecimal system, etc. Have you learned about number systems in your digital electronics class? Decimal system, hexadecimal system, conversion between binary to decimal, etc. Have you learned? No one?
No, sir.
Huh? This time you have some electronic fundamentals or something, right? Digital electronics.
It's last module, sir, not a
Okay,
time.
yeah, we are not dependent on that anyway. There are multiple number systems. Binary number system, only ones and zeros will be there. Decimal number system, 10 digits are there. That's why we call it as decimal number system. 0 to 9 are the digits used in. Similarly, there is a number system called hexadecimal number system where 16 digits are there. So that you will learn, but we are not dependent on that. Finally, it is a number, whether you represent it as a binary or in decimal or in other number system. Basically, it is a number. The magnitude in different, it's like magnitude in different number system will be slightly different. Something like, you have Indian rupee, and 1 rupee, if you convert it into $1, the value remains same, but the magnitude will be different. 1 rupee, if you convert it into dollar, not in $1, if 1 rupee, if you convert to dollar, it will be some point, some dollar, 0.05 kind of dollar. It will be 1 rupee. Or $1, if you convert it into rupee, 74 rupees. But even though the magnitude is 1 and 74, the value for that is same. Similarly, any number, whether it is represented in binary system or decimal system or any other number system, the magnitude may differ, but the value of that number remains the same. Okay, now address are normally address are integers, whether you represent it integer in decimal system or binary system. They are basically numbers or integers only. So here is an example. 1 is represented in binary number system with 32 bits, 16 bits. So this is a bit, this is decimal digit 1. So this is how it is. Okay, if 2 is represented in binary system, it will be 1 followed by 0 in this binary system, like that. So that conversion and all you will learn, but our focus is not like that. So what I want to say is, uh, every byte in the memory has a unique address. That address is used for accessing that memory. So 1000, if the address of this byte is 1000, I can, when I know the address, I can access that. That is the idea actually. Even though we are not doing it so far, we are not doing it so far. The idea is that when you know the address of something, we can access it. If I know your home address, somehow I can send a message to snail mail to you, or I can even come to your home. Okay, that way. So if we know the address of a byte, the idea is that we can access it using that address. But so far we are not doing that. Okay, we are not dealing with the direct access to memory, computer memory. Okay, now how it is related to variable declaration. Suppose we are creating a variable. This also I explained many times before. When we are creating a variable, say int x, I am creating an integer variable. I have told that in memory certain bytes will be allocated. So assume that this is a 16-bit machine. One integer is allocated with 16 bits or 2 bytes. 16 bits means 2 bytes. So that is what I have done here. So when I am declaring this, 2 bytes will be allocated in the memory. So these 2 bytes are allocated, and the value I am putting there, it's binary equivalent. In computer memory hardware, basically at lowest level they are all bits only, zeros and ones. So the binary equivalent of this decimal digit 1 is stored in that 2 bytes. Okay, so this is the binary equivalent. So first 8 bits are stored here, and remaining 8 bits are stored here. That way you can. Okay, now 2 bytes are there. Actually my variable occupies 2 bytes in the computer memory. If it is a 32-bit machine, it will occupy 4 bytes. An integer will be of 4 byte size. It will occupy 4. So just for simplicity we are assuming that it's 2 bytes. Now which are the addresses of those bytes? 1000 and 1001. Since these are, every byte is addressed. If this is 1000, address of this byte is 1000, the address of this byte is 1001. Okay, in that linear fashion the addressing of bytes happen. So 1000, 1001, 1002, etc. It's going upward. Okay, so this is memory address. Every byte is assigned in computer RAM or primary memory. Every byte has a unique address, and when you are creating variables, you are reserving certain amount of bytes, certain number of bytes. If it is an integer variable, 2 bytes are reserved. If it is a character variable, size of a character variable is normally 1 byte. So here char y equal to a. So the binary equivalent of a is stored in. So another byte is reserved at address 1003, and we call that as y. Here we call the memory allocated, that 2 bytes allocated to integer. We on the whole we call it as x. So whenever we want to access the data stored in this memory, we use x. Or whenever we want to store new data, what we do is we do x equal to something else, say x equal to 2. So if you do x equal to 2, what happens? The binary equivalent of 2 will be stored here. This whole thing will be erased and it will be overwritten by binary equivalent of 2. Binary equivalent of 2 is basically 1 0. All zeros, 14 zeros followed by 1 and 0, total 16 bits. Okay, so this is what is happening normally. So far we have done. Okay, we have not come to pointers yet. This much is clear, is it? Every byte in computer memory is having a unique address. When you create variables, certain number of bytes will be assigned depending on the type of the variable. If it is integer, 2 bytes on a 16-bit machine. For character, 1 byte will be assigned, and whatever value you assign to the variables will be stored in those memory. Okay, and using the variable names, we can access the data stored here. So when I do printf %dx, actually the data from these bytes are accessed, and that is taken, accessed or read from those bytes, those memory bytes, and that is displayed onto the screen. Or when you are assigning it, these byte, the data stored in these memory locations will get modified, and these are the addresses. Now what if we, how do we know this address? That is first question. We know that x is allocated with 2 bytes. We assign to x, data gets stored here. We use x in printing or in some expression. Data will be taken from here and used for processing or computation. How do we access this memory? There is an operator called address operator. Previously this was used as a bitwise AND operator, and there it was a binary operator. Two operands were there. Now using address operator, we can get the address of a variable. Using the address of a variable. So example is here, ampersand x. If I put ampersand symbol before a variable, this is a unary operator, only one operand is there, that is the variable following it. Now if I apply like this, I will get the address of this variable. Now what is the address of a variable? Actually this variable has 2 bytes. So whenever there is only 1 byte allocated to a variable, it is simple, address of that variable is this value. But when there are 2 bytes or more than 1 byte is allocated to a variable, address of that byte is taken as the starting address of that. Address of that variable is taken as the starting address. Now we have 2 bytes as allocated, 1000 and 1001. In that, assume that this is the starting address. So this will be treated as the address of this variable. Okay. If it is a single byte variable like character variable, this will be taken directly, only one address is there, that is the address of the variable. Now if there are more than 1 bytes allocated to the variable, the starting address will be taken as the address of the variable. Now when I am applying the ampersand operator or the address operator on the variable name, we get address. Okay, understood so far? So every step you have to understand, otherwise next step will become difficult for you. Hope everybody understood that and understood this one, whatever I explained. We are going to the code and we are going to see that literally. Okay. So same thing I am doing. I am allocating with value 10, x is equal to 10. I am creating a variable integer x equal to 10 and I am printing the value. That means using the variable name x, I am accessing the data stored. So in the computer memory, the binary equivalent of 10 is stored. This allocates 4 bytes. My machine is 32 bit, so this allocates 4 bytes for integer variable. You can get it using size of operator, size of x. And I am applying ampersand on x. So this operation should be giving me the address or the address of the starting byte of variable x. 4 bytes are allocated. Out of that, the first 2 bytes address will be given by using ampersand operator. Okay, we'll see what happens. And since it's a number, I'm treating it as an integer and printing it %d. So we'll see how this program works. Okay, we'll forget about this now. Okay, so x is equal to 10, printed the value I assign. Now address of x is obtained by applying this. So this is the address of the variable x. In memory, for the out of the 4 bytes allocated to variable x, the starting address or the 1 bytes address is this, or the first 2 bytes address is this. It's a number basically. Since it is a number, I can print it in decimal format using %d. If I want to express in hexadecimal format, instead of %d, I will apply %x. So previously it was decimal format. Now it is hexadecimal number system. In hexadecimal number system, you have digits F, E, etc. A, B, C, D, E, F. They are the digits in hexadecimal number system. 0 to 9, 10 digits followed by A, B, C, D, E, F. Okay. Total 16 digits are there in hexadecimal number system. Normally addresses are expressed in hexadecimal number system. What I need to do is simply change percentage %d to percentage %x. Okay, there is one more way to print it using percentage %p. Since it is an address, we can use formatting percentage %p. That way also I can print. So I will print it in 3 different ways, treating it as a treating the address as an integer, decimal integer variable, decimal integer value. I can use percentage %d, hexadecimal value, and percentage %p. We'll just see the difference. These are all the address same. Basically, we are converting into different units. I can say different units or different number system. So in decimal, this is the value. In hexadecimal, this is the value. When we are printing in p using p percentage %p, this we get. Basically, this is also hexadecimal only, but the formatting is slightly different. It is represented using uppercase. 61FE is smaller. Here it is using uppercase. Otherwise, this is also hexadecimal. Here preceding zeros are omitted. Actual address is actually this much big. These are hexadecimal digits. So for each hexadecimal digit, there is the binary representation is made of 4 bits. 4 bits. So C in binary, it will contain 4 bits. One is 0001. This one is 1110. So in every digit in hexadecimal system occupies or requires 4 bits in binary number system. That way 16 digits are there. Total 16 digits are there. That means 16 into 4, 64 bits will be there in binary number system. Okay, since preceding zeros are not having any value, here it is omitted, but here it is showing the preceding zeros also. This is actually a 16-bit address. Actually my machine is 64-bit machine. In a 64-bit machine, an address will have 64 bits. Memory address will have a 64 bits. Okay, essentially what I mean to say is, if it is complicated, just you understand that by applying address operator before a variable, we get the memory address of that variable. That's it. Memory address is a number. Basically we can display in a different number system this manner. So hereafter what we will do is we will not follow this. We will assume that it is like display it in decimal number system only. Okay. So variable x, address of variable x is this. It's a number displayed in decimal number system format. Okay, so far clear? We have not come to pointers yet. We are playing with variables and address of variables. Now you already know that if I want to modify this value, a value stored in variable x, what I need to do is x is equal to assign a different value. Or if I want to access it, we use it, simply give the name, we get the value. Or if you want to access it in an expression, say int y equal to x into 10. So what happens is, from the memory corresponding to variable x, the data will be taken. So 15 is stored in that memory and that data will be taken. So this will become 15 plus 10. This is how we are accessing it. But there is one more way to access the data. Since I know the address, or I can now know the address of this variable, using that address also we can get that data stored in x. We don't need to rely on x every time, variable name. X is the variable name. Now there is an alternate mechanism. Address of the variable I know. By applying ampersand I get the address of the variable. If I know the address of the variable, Using that address, we can get the data. So two ways we can do it. Now, one is the normal way using the variable name. If we want to write the data into that data, we assign new value to the variable. If we want to read data or access data, we use the variable in an expression or in a printf message like this. Now the alternate way now we are going to find is using the address of the variable. Okay. Now yeah, so this I know the address. Now we are going to learn using this address how we can access the data. Okay. In C, these addresses are stored in a special type of variable. Addresses are stored in a special type of variable. Typically, I can say I can create a new variable. I can create a new variable into y equal to ampersand x. So address of the variable, I can store it in a new variable. Okay. Now the problem is that I told address of a variable is 16 bits. 16 bits. Now my integer will be of 64 bits. 64 bits. Address of since my machine is 64-bit machine, address will be a 64-bit value, and my variable y is only 32 bits. So normally we will not use normal variables like this into y integer variable to store the address. Instead of that, we use a special variable called pointer variables. Special variable called pointer variable exclusively for storing memory addresses. So that way our definition of pointer is here. Pointer is a variable that stores memory addresses. We will not use normal variable to store memory addresses. Instead of that, we will use special variable, and they are special variables used for storing memory addresses exclusively, or whatever you store in a pointer variable, that will be treated as a memory address. Okay. Now how do we create a special variable or pointer variable for storing memory addresses? Very simple. If I want to create a pointer variable, specify the data type. Okay. So, and before the variable name, put a star. So creating a pointer variable is simply putting the star, a star symbol or asterisk symbol before the variable name. Okay. Now size of this pointer variable will be 64 bits. Size of this pointer variable will be 64 bits. Px is the pointer variable, and to indicate that it is a pointer variable, we have to provide star. If I simply declare p into px, it is a normal integer variable. So to differentiate between a normal integer variable and a pointer variable, we use a star symbol. Okay. Now, so remember, variable name is px, star is used to indicate that it is a pointer variable. So the compiler will know that compiler here it has to create a pointer variable. Now once I have this variable, I can assign address to this. Now address of my variable x is 64 bits, and my pointer variable is also size is 64 bits. So this complete data can be stored in this pointer variable. Once I have the pointer variable, I can access the data stored in this variable. Actually my pointer variable is now pointing to or referring to x, and it stores the address of this one. So to understand that, I'll just print the value stored in px. So address of the variable, here we got it using ampersand operator, and since I am assigning that into the pointer variable, when I print the value of the pointer variable, that is also same. So both these ampersand x or the px, both are containing both are giving the address of my variable x. Okay, now I will take you to another representation, or in the another diagram. Pointer is also a variable. Some amount of memory will be allocated for that. I told it will be allocated with 64 bits, or in bytes it will be allocated with 8 bytes. Since I am using a 64-bit machine, 64 bits means 8 bytes. So my pointer is having 8 bytes allocated to it. So when I create, so I am here int x is equal to 10. What happens? Some memory will be allocated in the computer memory. Some bytes will be allocated in the computer memory, and the value stored will be 10. 10 is 10, or the binary equivalent of 10. This 10 is decimal number, and we call it as x, and assume that the address is 1000. Same thing here. When I am doing x is equal to 1, 2 bytes are allocated. 1 is stored here. 1, or the binary equivalent I am showing here, binary equivalent of 1, and the address is 1000. So same thing I am showing here. Okay. Now I am creating a variable. Assume I am creating a variable, pointer variable. So pointer variable is also a variable, and some memory will be allocated that to that. So when I am creating, some memory will be allocated to that. Assume that as 8 bytes, assume 8 bytes or 4 bytes are allocated to this, and address of the first byte is 1020. Address of the first byte of the pointer variable. Now when I do px equal to ampersand x, what is ampersand x? Can anyone tell? Seeing this diagram, what is ampersand x? X, if you refer, it gives you 10.
Thousand, sir.
Yeah, ampersand x is address of this variable, that means 1000. I'm assuming that first byte's address, there are 4 bytes or 8 bytes allocated for this integer. First byte's address is 1000. Similarly, here 8 bytes are allocated to this pointer variable. First byte address is 1020. So when I do ampersand x, what I am getting is address of variable x, that is 1000. And if I am assigning it to pointer variable, what happens? The data stored in pointer variable will become 1000. Pointer variable stores the address of variable x. So this one I represent using a connection. So when I do this operation, when this is performed, a connection is established between, that means address of this variable is stored here. That means if I have this value, I can go to this memory location and get this data. Or in other words, I can say pointer variable px is pointing to x. Pointer variable px is pointing to x. Before doing that, I could not say pointer variable px is pointing to, so it was unknown value here. Before this initialization, it was an unknown value here. After I do this initialization, after I do this initialization, 1000 gets assigned here. That means logically I am representing pointer px is pointing to x. Now the advantage is that if I want to access this data, one way already I know using the variable x. If I want to store a new value, x is equal to 15 you put. If I want to access it, you just use x and you get the value 10. Display printf %d comma x. You get this value. Now I have one more mechanism. Using this pointer variables which stores the address of x, I can get this data. I can modify this data. How do I do that? That is, for that also there is a specific syntax. Now px pointer is pointing to variable x as per this diagram, or as shown in this diagram. Now I am going to access the data stored in, so this I will comment now. I am going to show you using the pointer variable how I am going to access the data. That process, if you have a pointer variable pointing to a normal variable, accessing the data stored in that variable, normal variable, using the pointer variable is called dereferencing. Okay, so I'm going to do that using the pointer variable. I have to specify px because px is having the address of the variable x. So I have to use that address. Before px, put a star. So when I do star px, I get the value stored in the variable x, and we call it as dereferencing. Px is pointing to variable x, or px has stored the address of variable x. Now using that address, if I want to get the value of variable x, I can apply star operator before the variable px, and if I run this code, or to differentiate, I can put star px, because using star operation, or we call it as dereferencing operator here. Dereferencing operator, I am getting the value stored in the destination of px. Px is pointing to variable x, so the destination is x. The data stored in destination I can access using. So I am using both the mechanisms now. First one is using the variable name. Second one is using the address of that variable. Address of that variable is stored in a pointer variable px, and by dereferencing that variable, I am getting the data stored in that variable x, or where px is pointing to. By this statement, we are enforcing that px, pointer variable px, is pointing to variable x by assigning the address of variable x into the pointer variable, or storing the address of variable x into the pointer variable x. So accessing the data is done. Okay, now how to modify the data using the pointer variable? Using the normal variable, we know how to modify the data stored in x. I can as simple as this. Now if I want to modify using the pointer variable, what I can do is star px equal to whatever value we want to put. Okay, so if I do this, what exactly happens is, so I will put this statement here, star px equal to 50 I am putting. So what will happen is, in the destination of pointer variable px, the destination of pointer variable px is this. Px is pointing to this variable. In the destination, this value will be put. So if I am doing this, what happens is as good as putting 50 here. We dereference the destination using pointer, and that means we get access to this one. We access to this memory location, and we put data directly there, 50. Okay. So if I print again, if I dereference and print, what will be the output? What will be the output? See this diagram. Now 50 is there, and my px is still pointing to this. So if I do star px, if I display with star px, what will be the output? Can anyone? So you see this diagram. When I am doing star px, what happens? 50 goes on. Previously it was 10 because of this. Now in the destination 50 is stored, and whatever value I stored, I am accessing from there. So I get 50. Is it clear? Any question you can ask. This is very fundamental concept about pointers. So what we are doing is we have a normal variable and we take the address of it and store it in a special variable called pointer variable. How we create that special variable is by putting a asterisk symbol before the pointer variable in the declaration. So we got the pointer variable, and in the pointer variable we store the address of the variable. So now we can use either the name of the variable or the address stored here to access that variable, to access this variable x or this memory location. Now I started modifying using that. I accessed the data here using that variable and it was printing 10 because it was 10 here. Accessing the reading the data. Now if I want to assign data or store data in that variable, I can do this way. So 50 is getting assigned here. Okay. Is it clear? Now what if I print this one? If I print x is equal to this one, what will be the output? This you have to tell. What will be the output?
50.
Yes. Because using this px is pointing to variable x, and here what I am doing is in variable x, in the using the memory address I am modifying the value of x. Instead of doing x is equal to 50 or x is equal to 20, since I know the address, using that address I am storing 50. So what happened, according to this diagram only it is clear. Now if I apply star px, I get 50. If I simply use x, then also I refer to the same memory. Because of that I get 50. So this is the whole picture. You directly get the address of a variable. Using that address, you access the data directly or modify the data stored in that variable directly. Direct operations, no variable names. Variable is now like a looks like an mediator. Variable was an easy mediator we were using to access the memory, to store data or to read data. Now I since I know the address, I can directly go there. Okay. So this is the very fundamental concept of pointers. In this, if you are clear, like rest of the things will be easy for you. If any question is there, you can ask me. Okay. If not, I will print one the size of this pointer variable. We know that size of an integer on a 32-bit machine is 32-bit machine or 64-bit machine, it is 4 bytes. But size of a pointer variable need not be 4 bytes because it has to store the address values, and the size of pointer variable will depend on what is the size of address values, size of these values. On a 64-bit machine, it will be 64-bit size or 8 bytes. So I'll show you size of a pointer variable. Size anyway it is in bits, so I'll put percentage d only. It is in bytes, so I'll put percentage d only, and I'll apply size of operator. Px is my pointer variable. So you can see 8 bytes. So since my machine is 64-bit machine, an address will be 64-bit size. 64-bit means 8 bytes. 8 into 8, 64. So size of the variable, size of a pointer variable is fixed for a machine. It depends on the memory size of the memory address. But size of an integer need not be size of the pointer variable. Size of an integer here is 4 bytes only. You know that. Size of an integer is 4 bytes only. In this machine, or in a 16-bit machine, size of the integer will be 2 bytes. So if you understood this concept I explained so far, this is the fundamentals of pointers in C. Size of integer in my machine is 4 bytes, but size of a pointer variable, it depends on the memory address, size of the memory address, and since my machine is 64-bit, it is 8 bytes memory address or 64-bit memory address. But integer remains to be 4. Any question is there, you can ask now. So now we know how to create a variable, pointer variable pointing to pointing to an integer variable. I put int star because this pointer variable I want to use for pointing to an integer variable. Suppose I have a character variable char a or ch equal to a, and if I and one byte of memory is allocated for this. If I want to create a character variable, a pointer variable pointing to this, I should create char star. Char star, I will say naming is up to me, so I will put char star pointer variable name and pch equal to ampersand ch. Now I have a pointer variable, 1 byte is allocated and it has an address. That address is stored in pch. Now if I want to access the data, printf star pch. I will apply star operator before the pointer variable name, and what we want to display is a character. Because of that I will put %c. What I will do is I will dereference it, star pch. So star pch equal to a. Or if I simply print ch is my character variable. So I am using the original variable name or using the pointer variable pointing to that variable, pointing to the original variable. Either way I should be getting same value. Now if you have a floating point variable, you create a float star pointer variable, or if you have a double variable, you create a double star pointer variable to point to the double variable. Likewise, for any data type, you can create a corresponding pointer which points to that normal variable. Basically, it stores the address of that normal variable. So this much for today. Any question you can ask me now, or if you did not understand anything, watch the video and be clear with this concept. This is very nice, powerful. Actually, pointers is a very powerful concept in C, and it is available in C++ also. And other languages like Java, Python and all, this concept is not there. Because C, and mainly because it is a very powerful mechanism, you can access the computer memory directly without any intermediary like variable names and all. And because of that only, since it is a powerful feature, it is high chances that people will misuse it. Okay, to corrupt the computer memory or crash it, there is a chance that people will misuse that. So because of that only, it is not available in languages like Python, Java and all. You can find in C++ you can find.